Hey mathematicians, here are your notes for 12.8, day 1, talking about mixed expressions and complex fractions. So, bell work, mixed expressions, what does that mean to you? Go ahead, write something down, and then come on back, we'll talk through it together. All right, so when I think of mixed expressions, I think of fractions. Fractions have been really important this entire chapter. So it's no wonder they're coming in handy now. Think about a mixed fraction. You've got an improper fraction that's going to be 4/3. You've got a proper fraction that's going to have a numerator smaller than the denominator, like 2/3. But the actual a mixed fraction would be like 1 and 1/4. Something that contains both a whole number and a fractional part. It needs both to be considered a mixed fraction. So it makes sense that when we're talking about a mixed expression, we're talking about something that perhaps has a whole number plus a fractional part to it. That's what makes it an expression, is it has a variable attached to it. So today's goal is to be able to simplify these mixed expressions and turn them perhaps just into one fraction. So let's get to it. Algebraic expressions such as a plus b over c and 5 plus the quantity x plus y divided by the quantity x plus 3 are called mixed expressions. Changing mixed expressions to rational expressions is similar to changing mixed numbers to improper fractions. So let's write each one of these as a rational, i.e. we're just going to simplify and turn it into one fraction. So if you'll think back to 12.7, the whole goal was to get a common denominator. Get a common denominator. So for this first one, right now we have, there we go. Let's zoom in on this a little bit. That's what I wanted. We have the fraction 5/1 plus 2/n. However, we can't add these because they don't have the same denominator. But it's just as easy as 12.7. We're going to do the same exact skill. If we need an n on the bottom of this, we're going to multiply by n on top and bottom. And because we're doing it to both the top and bottom of this fraction, we're not actually changing anything. We're just multiplying by a big fancy 1, which doesn't change the expression. So when we do that, we're going to get 5n divided by n plus 2 divided by n. When we simplify this and combine like terms, there are none in this case, we're just going to get 5n plus 2 divided by n. Let's see another one like that. The next one, we have 2/1 plus n plus 3 divided by the quantity n plus 3. Again, I notice this one has a 1 in the denominator, and I need there to be an n plus 3. So I'm going to multiply the whole thing by n plus 3 divided by n plus 3. Again, as long as it's the same on top and bottom, we're not actually changing anything. The kicker here is that since I now have a monomial times a binomial, I do have to distribute that 2 when I simplify. I now have 2n plus 6 divided by n plus 3 plus 3/n plus 3. Now we're used to breaking this up and simplifying in 12.7. Now we're just going to combine 2n plus 6 plus 3. 6 plus 3 is 9, so we now have 2n plus 9 divided by n plus 3. That is your answer for that one. All right. Next one, we've got 4/1 plus 6 divided by a. Same thing we did before. This previously had a 1 underneath it. I need it to have an a, so I'm going to multiply by a over a. I get 4a divided by a plus 6 divided by a, which simplifies to 4a plus 6 divided by a. Notice, just like in all my other chapters, I am not adding the denominators. It's just a common denominator. I'm not adding it, I'm just transferring it over. What about when subtraction is involved? These were all addition examples. Let's see one with a difference. So I've got 4 divided by x squared minus 2. I currently have a 1 as my denominator, and I need there to be an x squared. Whatever I do to the bottom, I must do to the top. So when I simplify this and rewrite, I'm going to get 4 divided by x squared minus 2x squared divided by x squared. These are not like terms. They do not have the same variables with the same exponents. So I just get to write 4 minus 2x squared divided by the quantity x squared. The big thing is just making sure that subtraction goes all the way through if there's more than one term. Let's look at that now. So this one needs a denominator of m minus 2. When I do this, I'm actually going to distribute negative 2m onto both of those terms, and then I'm just going to add. So here's what that's going to look like. I have 4 divided by m minus 2 plus, when I do negative 2m times m, I get negative 2m squared. When I do negative 2m times negative 2, I get positive 4m. Now I've officially turned this into, into an addition problem, so now I can just add those like terms. In this case, there are no like terms in the numerator, so I just get to rewrite them as negative 2m squared plus 4m plus 4 divided by m minus 2. All right, go ahead and try that last one on your own. Pause the video and then come on back and we'll try it together. All right, let's try this last one together. We've got 1 divided by 1 plus 1 over x. So let's go ahead and give that an x in the denominator and an x in the numerator. Now I have x over x plus 1 over x. When I simplify, I get x plus 1 divided by x. Those are your day 1 notes for 12.8. Please don't hesitate to let me know if you have any questions.